Okay, so if you remember from last time, I was talking about this particular one. The study needs to compare the erosion potential of different watersheds. In the big picture now, we have rivers and streams in the landscape. Those rivers and streams drain a certain area, these watershed areas. And she wants to know, of the watersheds, which ones have more risk of erosion than others. And she basically gives us some clues as to what makes one more erosive than another. Anything with high slopes, so the higher the slope, the more erosion potential. The next one is when it comes to vegetation. If there's thick vegetation, it makes a decrease, so it's a negative relationship to erosion. And then it's also decreased, so both vegetation and the high soil infiltration, both of those, if you have higher infiltration, higher vegetation, it brings down the erosion potential in both those cases. So a negative relationship between those two variables and a positive between slope. And so the very first question that comes up in this set is question 6, and it has us working with the canopy raster, as in forest canopy, how much canopy cover there is. And in this particular case, she wants a raster named canopy effect. So we're going to use the GIS layer called canopy, and then we're going to output one called canopy effect. And it uses the formula 100 minus the canopy divided by 100. And so you think about the mathematics of why she's doing this here. Remember, the more canopy, the less erosion. So that's why you're taking the canopy, a 100 minus the canopy. So if you had 100% canopy or 99% canopy, you'd have a very small number over 100, which is going to make for a small overall number. Whereas if you have 100% canopy, if you have a very low canopy, like 2% canopy, it's going to be a high number. And so this is going to vary from 0 to 1, and it's going to be where a low number of canopy is going to result in a relatively high value of canopy effect. That is to say, what kind of effect that'll have on erosion. So, very little vegetation will lead to high erosion, and a lot of canopy will lead to low erosion in this case. So that'll be what we do in number 6, and then we're going to get to the infiltration part for number 7. So let's take a look at 6 first. What she wants us to do for 6 is bring in that canopy layer and then run that formula. If I go to add data, we want to go to our MGIS data. This is going to be Black Hills and the Sturgis folder. And she wants the canopy and raster. And remember from our previous problem, we want everything to be in 30-meter resolution cell size for our environments, and also the default for the extent. So I'm going to go ahead and set that as well on this map as well. So analysis, environments, and the extent we want default, and the cell size is already set to 30. So remember that from our previous project. All right, so let's take a look at the canopy here, legend, and anything in these light shades are low values, so 1s and 2s, and anything that gets to darker and darker, up to 99% canopy cover, gets to be these dark shades of green. I am not entirely sure why the numbers go past 100, but they seem, I don't see any black out here, so it's almost like they're not really values that are being used. I don't quite understand this layer, but we'll see how, we can assume that if we run this formula through it, it's going to work out. We'll see. Also, I like to take a look here, what's the cell resolution of this layer itself. So I can go to the source, to the raster information, and it in fact already is 30 by 30 meter raster cells, so it's going to be a compatible data set to our analysis environment. All right, so to run this one, the tool we're going to use for this is just the raster calculator. Anytime you're doing mathematics with raster layers, that's a go-to, maybe one of the most common tools that we'll use in Chapter 11. So I'll go to Geoprocessing, raster calculator, and all I'll need is that one particular layer. I'm going to go ahead and put the parentheses in here as she suggests. So it's going to be parenthesis, need to go back to it real quick here. She wants it to be 100 minus canopy. So for this, I can just type in 100, but I do like to use the operators from over here because it gets the right spacing. I say that, and then it didn't give me a space there, so I like to add a space there. Double click on Canopy to bring that down. So you want it to look like that. I guess I did have an extra space. Next up, I'll put my end parenthesis at the end. And then this is going to be times 100, I think is what that was. That's leaving some weird little things behind there. Okay, and she had a suggested name for this. Anybody remember what that name was? Canopy Effect, was it? Is that right? Okay, so 100 minus Canopy, and then times 100. I'm going to go ahead and hit run. While I'm hitting run, I'm going to go ahead and check that. Canopy Effect, and then, oh, divided by 100, darn it. I'll run it again. We can ignore that one. So we just need to go back in here. These tools work better. If you make a mistake, it's better to go back out and then back into it again to clear it out. I hate to say. So 100 minus Canopy, come to the end, divided by, and then 100. I'll just put a 2 behind it just to Alright, so this looks better. Our answers are varying from 0.03, so a very small number, up to a value of 1. And again, this now is made in the same proportions. It's a positive relationship now because it's just inverted it to where a high value of this effect will lead to higher erosion in this particular case. So we'll end up using this later. So this is Canopy Effect 2, which is also the answer. The result, actually, I don't want to do that. I'm going to leave the name simple here. We'll just remember Canopy Effect 2. We're going to use that later in one of the future problems. So that's number 6. I'm going to go ahead and keep this rolling. We're only at 7 minutes in. That was a fast one. So then number 7 is to convert the SD Geology feature class to a raster based on infiltration. Reclass the low, medium, and high to values of 5, 3, and 1 respectively. So take a look at this. If the let's see, so low, medium, high is 5, 3, and 1 respectively. Divide the results by 10 to create a infiltration raster that varies from 0.1 to 0.5. And so keep in mind for this one, it ranged values from basically 0 to 1. This is going to go from 0.1 to 0.5 as we go to bring these values together. I just want to point out, and when you read Chapter 11, there is an aspect of some of this raster analysis where there is some subjectivity in terms of how the analyst decides to put the weights on these different factors. And so it's a little bit arbitrary. That's why really question number 10, which I'm not asking you to do, has you change some of these weights, some of the index values that you're using to see how sensitive the final map turns out to be. Whether you call it 0.1, 0.5, and 0.8, or if you call it 0.1, 0.2, and 0.3, the numbers are going to change. But again, they're not actually real numbers. You don't have real units on these. It's just an index that gives you a sense from high to low how much erosion could you have, or high to low, how suitable is the spot for a landfill, or high to low, how good is the spot for some kind of endangered bumblebee habitat, or whatever it is. And so, but you have to make some choices, and you can see in here she's putting in some choices. But if you're using analysis like this for your own final project, you yourself will have to make some choices about how you scale these values to make them all come together in a meaningful way. All right, so let's take a look at this. We need to add the SD Geology feature class. We know this is going to be a polygon layer to start with. We need to turn this into a raster, then we need to reclassify it, and then we need to use a raster calculator to divide by 10. All right, so a couple different ways to go about this. So let's just turn off this layer. I'm going to go to my map and find that geology layer. It's probably going to be in the features. And then looking for SD geology, there it is. And then I want to look at the attribute table. She's mentioning in there that in the attribute table itself, there should be something that has to do with infiltration. There's a high, medium, or high, mod, and low. Not sure why mod, but maybe that means some kind of version of medium. Let's just take a quick look at what she says about that. Reclass the low, medium, and high into 5. So low infiltration is going to be a 5, a 3, and a 1. Okay. So there's a couple ways we could do this. We could convert the vector polygons into raster using that column and do a reclass. That's kind of how she suggested it, so I'll go ahead and do it that way. But there's another way you could do it, and that is you could add another field onto this attribute table, and then you could essentially say if it says high, make it a 5. If it says medium, make it a 3. And you could have another column in there that's the 5, 3s, and 1s, and then convert that column into your raster. And it kind of would be like, it ends up being 3 steps either way. It's whether you do the step here or you do the step in a reclass step. I'm going to go ahead and do it with the reclass step. Anybody, you guys remember what tool we can use if we want to convert from polygons to raster? This is going to be in the conversion set. And I think it's the one she wants us to use is feature to raster. And in this case, it'll be the SD geology. And then remember, we need to give it which column in the attribute table do we want to use. And we want this one to be the infiltration one. It's going to make a GIS layer. So I'm just going to call this, I'm in step 7, so 7, and I'll just call this problem 7-1, and it's going to output 30 meter resolution cell size because this is the part 1 of problem 7. And so I'll go ahead and run that. So this is going to be a raster version of the infiltration, and that adds it here. So high, medium, and low. And then the next step is to do a reclassify on it. In this case, it's going to be the first part, the infiltration, and she has suggestions on what numbers to put in here. I'm going to call this one this is the part 2 of the problem. So I think she had this as the high, let me have to look this up. So high, was it 1, 3, and 5? Anybody have that open? Was it okay? So 1 for high, 3 for the medium, mod, whatever it is, and then 5 for that one. We're going to keep no data as no data. So it's going to make a raster that looks just like this raster here, but instead of the high, medium, low, it's just going to be values of 5, 3s, and 1s. And then the last step then is she wants us to divide that by 10, so it drops all those numbers down by an order of magnitude. So let's just make sure that looks right. So it's the same polygon, the same regions, but just now. But we see it still says high, medium, and low, but I think if I go to the symbology, I should be able to change this from infiltration to the value. And now it's the 1, 3s, and 5s in the legend. Okay, so last step then is to go back to our geoprocessing. and in this case raster calculator. And in this case, we're going to take the reclass of problem 2, bring that down, divided by a value of 10. And she did have a suggested name for this one. This was going to be infill effect. Okay, so I'll go ahead and run this. So we've got our equation is just divided by 10 of that raster. And so we'd expect the values now, and we see this to range from 0.1 to 0.5. In fact, it does. If I was to change my symbology from a stretched into a unique value, we should then see that this one also is the 1, 3, and 5 across those different colors there. I'm not sure why it has all those decimal places, but it's effectively 0.1, 0.3, and 0.5. Okay, so let's get out of the Zoom. I think that's the answer to 7. And let's go ahead, let's see. So the last 2 steps here is to calculate the erosion index of the slope 30 times the canopy effect times the infiltration effect, and then number 9, determine the mean erosion index for each watershed. So we have 2 more steps. I'm going to go ahead and stop this one. We've gotten up to 16.